Bismillahirrahmanirrahim. In the name of Allah, the most gracious, the most merciful. For everyone, I hope you are doing well. Inshallah Rabbil Alameen, today we will talk about the pressure. Okay, let's talk about the pressure, inshallah Rabbil Alameen, to finish our portion, inshallah. Number one, when we talk about the pressure, we have to understand the following. If we have a surface, any surface, okay, and this surface like this is a surface. You have any surface like this, and this surface is affected by an a force like this. Okay, so now we have two things. Force affects a surface, so we can talk about the pressure, which is the magnitude of the force, this force, which is acting perpendicular to or normal to the unit area of the surface. يعني the unit area of the surface. And for example, imagine that the force is 10 newtons and the surface area is 5 meters squared. So simply we can find the pressure by finding the force that's acting on 1 meter squared unit area. Okay, so we will divide, to find that we will divide the force, which is 10, over the area, which is 5, to find the force that's acting normal or perpendicularly to the unit area. So from this argument, we can say that the general formula for calculating the pressure is P equals F divided by A. F is the normal force, okay? Or even if the force is not normal, there is some mathematical way, which is not included in our syllabus, okay, to find something which is called the vertical components of the surface, of the force. Okay, but now we will say the normal force, or the force that's perpendicular to the surface, okay, divided by the area. So F divided by A. F is measured in newtons, area is measured in meters squared. So we can logically conclude that the expected measuring unit of pressure is Newton per meter squared. Newton per meter squared. But in fact, the owner of a very famous scientist who was called Pascal, we call the Newton per meter squared as Pascal. Okay, so here the SI unit is Pascal. P A, okay, which so PA stands for Pascal, okay, which is equal to Newton per meter squared. Okay, here we can also, or you have to write also this unit, this equivalent unit, which is joule, which is joule per cubic meter. This is an equivalent unit, which is equivalent to this unit. Okay, how, Mister, can we get this unit? We can get this unit easily by multiplying both. This is Newton divided by meter squared. So if we multiply the Newton times meter, we know that from work, Newtons times meter means force times distance. So it's joule, okay? And so if we multiply in the numerator times meter, we have to multiply in the denominator also times meter to maintain the value constant. So Newton times meter will be joule, meter squared times meter will be meter squared, and this equivalent point is so important, inshallah Rabbil Alameen, to be known. Okay, so when you receive the PDF today, inshallah Rabbil Alameen, you have to add it yourself to the PDF. Type. Let's talk about the factors, okay, those affecting the force. From this formula, we can easily find the factors. The factors are, number one, the force, the applied force. Number two, the area. By the way, this force may be the weight. Yeah. For example, if you put a book on a table, if I ask you, how can you find the force that the table affects the book? Okay, sorry, the book affects the table. Okay, you can say that the force that the book affects the table is the weight of the book. Okay, so the force may be the weight. So I can say the weight because also. So force or the weight, sometimes it may be weight. As force increases, the pressure increases. It's logic. But you have to differentiate between the force and the pressure because the pressure is pressure, it's not force. Okay? And if there is, this is another quantity. طيب. Let's look at the second relationship. The second relationship is between the pressure and the area. Okay, the pressure and the area. As the area increases, the pressure decreases with the reciprocal factor. Okay, so in the first relationship, we can say they are directly proportional to each other. Okay, but our statement will not be scientifically accurate except for after saying that force, the pressure is directly proportional to force at constant area. At constant area. Remember that we said when we study the relationship between two quantities, we have to fix the other factors constant, okay, to make what we call the fair test. Okay, so also here we can say that as the as the surface area increases, the pressure decreases. The surface area increases, the pressure decreases, or the pressure is inversely proportional to the surface area at constant force in this time. طيب, based on this idea, we can conclude that as the area increases, the pressure decreases. Okay, so Subhanallah al-Ali al-Azim, when the human is standing on his feet, his weight is concentrated on small area. So with after some time, he may feel tired. But Allah subhanahu wa ta'ala made the human sleep on his side or where the side of the human, okay, when you are sleeping on your side, the side of the human is larger with a larger area than your feet. So this decreases the pressure of your body. Okay, so this makes you more comfortable. طيب, let's look at this example here. The design of the nail is considered to be a component of this idea, on this idea. Sorry, an application on this idea. The head of the nail is designed such that it has larger surface area. Why? To lower the pressure, to lower that pressure, to avoid breaking the nail. But the tip of the nail or the front of the nail is designed to be too tiny, okay, or too sharp. Why? To produce a large amount of pressure on the wood such that it can go through it easily. Let's have another example. Okay, now we have these 2 feet. These are 2 feet. 2 feet. Okay, this is a feet of an elephant, and this is a foot of an animal, an elephant. This is a foot on or the shoe, or especially we talk about the heel of the this shoe, shoe of a girl or a woman. Okay, which one will produce prints? Okay, will affect more the مثلا let's say wooden ground or floor, something like that. Okay, in fact, this why? Because it has too small area, so the pressure will be large. But here the elephant weight, although it's large, too large elephant weight, but it's distributed on 4 feet. The total energy, the total area is the area of the 4 feet of the elephant. Okay, so from this argument, we can conclude that the as the area increases, the pressure decreases. طبعا ان شاء الله رب العالمين I يعني as usual I listen to your questions after each period. But today, yani before, because we want to finish the portion, so please write your questions, okay, to avoid forgetting it now in front of you, okay, and inshallah, Rabbil Alameen, starting this period, okay, I'll begin answering your questions here in the discussion room, by the way. خلاص يعني I see your questions in the discussion room. Wallahi, I don't forget them, but I told you that we will begin answering these questions after finishing this topic and this portion to give us more chance to solve together inshallah رب العالمين. فما تفكروش اني مطنشكم يعني. تمام. This period, if I have a chance to answer you after finishing, I'll give you the chance inshallah. طيب, this is an example. Okay, the diagram shows solid block resting on a bench. This is a solid block. It's resting on a bench. Okay, the dimensions of the block are shown. On which labeled surface they should the block rest to produce the smallest pressure. Okay, by the way, in fact, at any surface, the force will be the same. Why? Because it's the same block. So it had the same force. Okay? So it had the same force. Okay? So we can, but what about the area? The base area here differs from surface to surface. Okay? Because this, in this case, when the surface is too small, when the surface is too small, sorry, if there is lagging voice عشان الانترنت لحظة. اوكي لحظة. طيب ممتاز. Okay, again, so here ان شاء الله كده الفويس ظبط تمام. معلش كنت بظبط بس الفويس. كنا بنقول the same weight will be of the same this block. Okay, so to get the smallest pressure we have to put it on the largest area. Okay, as we explained in the previous argument. Okay, so where is the largest area here? The largest area is 80 times 40. Okay, so this is the surface P, which is the answer number 8. طيب. Okay, here, this, if you observe, we wrote here, this is number one, general formula, the general formula. Okay, there are two other formulae, those we will talk about them. Number one, or the number two, يعني the formula number two, is the formula that's for explaining or for finding the pressure of a liquid on a point, at a point inside it. يعني, if we look at this beaker, we have here liquid. Okay, this liquid here has, if we choose any point, which is P, for example, here, or any point here on this height, if we observe that there is liquid above this point, so this liquid has weight. Okay, so we can find the pressure of this weight on any point here by the same formula, F divided by A. But sometimes the problem is it doesn't have it doesn't give you the weight, that weight. So we try to make an alternative method to find the pressure of the liquid, okay, yeah, on a point inside it. This method is P equals rho GH. Okay, what's meant by rho? P is the pressure, rho is the density of this liquid, G is the gravitational field or the freefall acceleration, and H is the depth of this point from the surface or the height of the surface above this point. They are the same. يعني two different expressions about the same thing. طيب. Here If we want to find the pressure of the liquid, only the liquid, yeah, above this point, we can use this formula. P equals rho GH. This formula, by the way, is derived from the formula that we used, the first one, F divided by A, okay? But the proof is not included in our syllabus. But يعني, inshallah, Rabbil Alameen, during the discussion or revision, we may say it يعني, just for ourselves, okay? طيب. So P equal rho G times H. طيب ممتاز جدا. Rho is the density of the liquid. So we can say that the factors affecting the pressure of a liquid on or at a point inside it, okay, are number one, the density of the liquid. Okay, so if you observe P equal rho times GH, so they all are on the same line. So we can say that the P and rho are directly proportional to each other. Yani P is directly proportional to rho at constant G and H. P is directly proportional to G at constant G, rho and H. P is directly proportional to H at constant rho and G. Well, so this is the liquid of what? Of the, this is the pressure of what? Of the liquid. But someone may look at the figure and tell me, Mister, but there is air above the surface of the pressure. Yes, طيب Mister, does this air have pressure? Yes, معروف. We know there's something called the atmospheric pressure or the air pressure. So this air will cause additional pressure on the same point. Yes. So if the question says find the total pressure or the absolute pressure on the point, we have to take this point with the, which is the pressure of only the liquid and add the pressure of the air to it. So the total pressure will be P of air, pressure of air, plus the pressure of the liquid to find the total pressure or the absolute pressure. Mister, so يعني this is the pressure of what? This is the pressure of the liquid only, the upper part of the liquid. بس. So if he asks me, he will ask me to find the pressure of the liquid on that point, the liquid pressure. لكن if he asks me to find the pressure without saying the pressure of the liquid, so he means the absolute pressure, the total pressure. So I have to add the air pressure plus the liquid pressure. طيب. Sometimes they call this value rho GH in some cases the gauge pressure, but this nomenclature is not included in our syllabus. انا مش عارف يعني I forgot وحطيتها كده وانا بكتب بس مش مهم. طيب there is a very important question. Mister, is this formula valid only for the liquid? No, in fact, it's valid for any يعني in this case if I have rho and the height of the side like this, I can use this formula. But there is one condition. To use rho GH for any solid object, this object should be with uniform cross section. يعني cross sectional area بتاعته doesn't change from point to point. يعني for sphere we cannot use this. We cannot use this for the sphere. We can use it for a cylinder, a cube, cuboid, and so on. طيب, let's go back to this slide. طيب, here, if we sketch the relationship between the pressure and the height, okay, or the depth, okay, this the curve will the gradient of the line will be rho g h rho g because it's rho g h. We take rho h as x-axis, so the quantity or the factor of x-axis is the gradient. دايما دي قاعدة. The factor, okay, besides the x-axis is the gradient. So the gradient here will be rho g. ممتاز جدا. طيب, if we have two liquids A and B, which one has larger gradient here? This one, which is the steeper one, because at the angle with h or with x-axis increases, it means that the gradient is more. So the steeper the line, okay, the more the gradient. طيب, ده كلام جميل قوي. So you want to say that the gradient here is more? Yes. So when the gradient is more and the gradient equals rho g, tamam, g is 10 if we are on the ground, okay, or close to the ground, g equals 10. So it's constant. In the same place, it's constant, okay? So which one of these two liquids has more density? In fact, the A has more density because it's steeper than B, or A is steeper than B. Type. Let's look at this question. A pipe full of water connects water supply on a hill to tap lower down the hill. ممتاز جدا. The length of the pipe is 500 meters. This is the length of the pipe. The height of the supply is 100 meters. The density of water, so here I have height h and have length. Length doesn't affect pressure. Pressure behaves, or pressure is affected only by the height or the depth. So the density of water is 1000. So I have the density of water, and G is given on the cover page, which is 10. Okay, and I have the height, so I'll not use 500. I'll use the height 100 and the density, which is 1000, rho gh 100 times 1000 times 10. So the answer will be C. Okay, type. This is another example, but we will solve it later after finishing the explanation. احنا كده عملنا بس ايه يعني application how to apply the previous formula. Now we will talk about the last point in the pressure, which is how can we measure pressure. In fact, measuring pressure can be performed by two methods in our syllabus. The first one is called the barometer. The second one is called manometer. Here, the barometer, in fact, it's used to measure the atmospheric pressure or the air pressure. So it's specified to the pressure of the air, which is called also atmospheric pressure. And it measures it not in Pascal, which is Newton per meter squared, but in another strange unit, or yani it may be strange for the first instant, but you will be familiar with it, inshallah. Millimeter mercury. Why? Let's understand. By the way, this great invention is related to Torricelli, but in fact, it's not the invention of Torricelli. It's invention of an ancient Muslim Arab scientist. لكن they call it Torricelli's barometer. Okay, this is the barometer in front of you. What is the structure of barometer? In fact, it's a pond, small pond or container or reservoir. Okay, this container has mercury, and this is a tube, as you see. It's filled with mercury, then flipped upside down in this container. After the mercury balance, okay, يعني stops at fixed position, there will be some vacuum above the mercury here. This vacuum is called vacuum or Torricelli's vacuum. Okay, as I told you, they relate this to Torricelli. Okay, Torricelli's vacuum. This vacuum, when you say vacuum, it means the pressure in it approximately equals zero. Okay, in fact, it's approximately equals zero because it doesn't have anything except for rare amounts or traces of mercury vapor. طيب يعني no air here. تمام, nothing here, is vacuum. ممتاز. So this is the column of mercury. Concentrate well. This column of mercury presses that point. Look at that point here, that point. Exactly. Okay, well. So the pressure above this point is the pressure of mercury. Concentrate well لو سمحتوا أرجوكم. The pressure above this point is the pressure of mercury only, nothing else. But the pressure above this point, which is along the same horizontal level with it, is The pressure of what? Here there is what? There is air. There is air. So because these 2 points here and here are on the same level, okay, the same horizontal level, it means they are affected by the same pressure. They are affected by the same pressure. So the pressure here, which is the pressure of air, equals the pressure here, which is the pressure of the column. Okay, so we will measure the length of the column. In fact, in ordinary cases, we find that the length of the column of mercury is 76 centimeters mercury, or we can say 760 millimeters of mercury. That means what? That means the pressure of air is the same as the pressure of 760 millimeter of mercury. Concentrate again. The pressure here of mercury equals the pressure of air. The pressure here, which is the pressure of air. Why? From where we got this idea, mister? Because they are on the same horizontal line. They are horizontal. You know, the pressure of air presses here. The pressure of mercury presses here. They are along the same horizontal line. It means these 2 points, because they are on the same horizontal line, they are affected by the same pressure. So they are balanced. Something like the two pans of the balance, when they are on the same horizontal line, it means the pressure here or they are balanced. Okay, the pressure here is equivalent to the pressure here, or the weight here is equivalent to some idea like that. Okay, here طبعا we are talking about the pressure, not about the weight. طيب. So because these on the same horizontal line, the pressure here is equal to the pressure here. The pressure here is air, because this is exposed to air. The pressure here, the pressure of the column of mercury. Okay. Someone may say, and the air here. No, I said here, this is a vacuum, no air here. Vacuum has nothing except for rare amounts, traces of water, of mercury vapor, whose pressure is zero, approximately zero. طيب. So we can say the pressure of air is equivalent to the pressure of this column of mercury. So in other words, we can say if the length of this mercury is 760 millimeter, we can say that the pressure of air equals 760 millimeter mercury. It means it's equivalent to it. Or we can use it in centimeters, 76 centimeter mercury. Or in meters, 0.76 meter mercury. Okay, if we change this unit, which is meter mercury, to Newton per meter squared, which is Pascal, we will find that the equivalent pressure will be 1.0.1.013 أو يعني 1.01 هنا times 10 to the times 10 to the power of 5 هي 1.013 باسكال. ممتاز جدا جدا جدا. ارجوك ركز معايا. يبقى here the reading of the barometer is the air pressure. الكلمه دي you have to repeat it to يعني like your name. The reading of the barometer is the air pressure, يعني atmospheric pressure. So we will use whenever I find it in a question, so this is the atmospheric pressure. أرجوكم الموضوع ده تريكي جدا عند كتير من الطلاب. طيب. So the air pressure, if I want to express it in terms of the millimeter mercury, I write the length only. يعني I write P of air equals Hg اللي هو الميركوري. يعني H يعني the height, which is 760 مثلا. 760 mercury millimeter. طيب, Mr. If we want to change it to Pascal, طيب, let's remember the pressure in Pascal is rho GH. Rho of what? Rho of liquid, because I want to find the pressure of the liquid. So rho of mercury, G times G, which is 10, times H of mercury, which is 760 millimeter. So when we multiply these three values, يعني مثلا rho of mercury is approximately 13,600 kilogram per meter cube. تمام. Times G is 10 times H, which is 760 millimeter. You have to divide it over 1000 to change it to meter. لازم تحولها لمتر. If you use rho GH, all units should be in SI units. لازم. Okay, so you will divide it over 1000, so it will be 0.76 meters. تمام. If you multiply them, you will get 1.013 times 10 to the power of 5 Pascal. ممتاز ممتاز جدا. So this is طيب. Mr. You wrote here a strange word. You wrote at STP only. I mean these values at STP. What's meant by STP, Mr.? STP is an abbreviation used to describe certain conditions called standard temperature and pressure. Okay, standard means standard temperature. So the standard temperature is 0. Okay, and the standard pressure is this pressure with these values explained in front of you. Okay, and these can be satisfied on the sea level, on the sea level only. Yani on the sea level, if the temperature is 0, the pressure will be this value. تمام. Let's go to the manometer. Manometer measures what, Mr.? Manometer, it doesn't measure pressure. It compares pressure. It compares the pressures, compares between the pressure that's enclosed in a container and the external pressure, which is the air pressure. For example, مثلا, you know that the gauge or the manometer that's connected to the water wheels to examine the pressure inside them, this is some kind of manometer. In fact, it's based on air enclosed in a container, and it makes comparison between it and the external pressure, which is the air pressure. Okay, so the manometer, it's used to measure the difference in pressure, delta P. Delta P, delta P means difference of pressure between a gas in a container and the atmospheric pressure or the air pressure in almost millimeter mercury or water. Water. Here we used mercury only in barometer. I'll explain the reason later. Okay. لكن in manometer we may use mercury or water. طيب ممتاز. طيب how can we take the reading? For example, here, this is the container. This is, here there is a container which contains the enclosed gas, the gas in the container. So this is to the gas supply. It's connected to the gas supply. Here there is a container. And there is some kind of tap or some valve or something like that. When it's up, when it opens, what will happen? This is the manometer. It's U-shaped tube, as you see. Okay, it has mercury. Before opening the gap, the two sides of mercury will be the same, on the same level, because here there is air and here there is air. يعني قبل ما نوصل, before we connect this to the gas. After we connected this to the gas, if the pressure of the gas is larger than the pressure of the air, so it will overcome the air. It will beat the air. So it will push the branch, the mercury in its branch more than the ability of the air to push the mercury in its branch. So here, this shows us what the gas pressure is larger, so it beats the air and pushes the mercury more. Okay, so you have to understand that the lower the level of mercury means the stronger pressure above it. Okay, ممتاز. طيب, so here Mr. How can we determine the difference in pressure? In fact, the difference in pressure is the difference in height, the difference in between the two levels. So the difference in pressure is the difference between this level and this level. So this is the difference in pressure. So the pressure of the gas can be, the difference in pressure of the gas can be expressed in, sorry, I'm here. The reading, which is the difference in the pressure, delta B equals positive or negative H. What positive and what negative? I'll tell you what's meant by positive and what's meant by negative now, but forget positive or negative now. خلينا H. H is the difference in height of Mercury. The difference in height of Mercury. Okay. Well, what about the pressure of the gas? If I want to find the pressure of the gas and I know delta P, yes, delta P is P air minus the B of the gas. خلاص. يبقى P gas can be obtained by taking P air from the barometer, and you will add or subtract H if you want to use centimeter mercury or millimeter mercury. Okay, we will apply on this formula. If you want to find it in Newton per meter squared, you will make the same formula, but all the units will be Newton per meter squared, and instead of H, I write rho GH. طيب, what about plus or minus? If the gas pressure is more, you will use plus. If the gas pressure is less, you will use minus. Let's take an example. What's wrong with you? Look at this. Here, in this example, if we look at this case, we said the lower the level, it means the stronger pressure on it. يعني هنا معناها the gas is higher, has higher density. By the way, احنا خلصنا الحمد لله, بس احنا بناخد example بسرعة. Here, which is the lower branch? It's the branch which is exposed to air. Here there is air. تمام? So it means the pressure of the gas is less than the air. So here the pressure of the gas is more than the air. Here the pressure of the gas not equal, I'm sorry, not equal, but less than the air, less, not equal, less than the air, okay? And here, because this is more than, we will add H, because this is less than, we will minus H, okay? If you want to find the unit with centimeter mercury, I will put H. If I want to find the unit with Newton per meter squared, I will put through GH. Alhamdulillah, I finished with the explanation in the theoretical part, and we will apply inshallah in the next session. If you have any question, you can ask now. I'll stop recording. Thank you, everyone.